Good morning, dear students. I am Dr. Srinivas Pattini, Professor of Chemistry in St. Peter Engineering College. Today, I am going to discuss the last topic, that is desalination of brackish water. What is the topic? Desalination of brackish water by RO method. By RO method. RO means what? RO, reverse osmosis. Okay, this is the last topic, very small topic. So till now, what we have completed up to today, because today is the last class, just revise that one. The topics are what? Just at least topics. The first topic is about introduction. In introduction, what we have seen? Sources of water, applications of water, impurities present in the water, then hardness of water, types of hardness, temporary hardness, permanent hardness, then potable water, purification, potable water, and its specifications. Then steps involved in the purification of water. Many steps are there: aeration, screenation, sedimentation, coagulation, filtration, in that. And then boiler troubles, scales and sludges. The troubles we discussed: scales formation, sludge formation, bicarbonates, calcium chloride and magnesium chlorides are sludges, and scales: calcium sulfate, magnesium sulfate, calcium hydroxide. These are the scales. And internal treatment of water, that is the conditions, phosphate conditions. Colgan conditioning. Colgan means removal of calcium gone. That is a Colgan conditioning. Colloidal conditioning. And estimation of hardness of water. We have to estimate that the laboratory experiment formulations are there by EDTA method, ethylene diamine, tetraestic acid, EDTA, already be completed. In how much of salt present in the water, that is they have used by the estimation method, by the complexometric method, by the EDTA. And then external method, the last class, ion exchange method, not geolite method. According to our syllabus, estimation, that is external water by ion exchange method. In ion exchange method, what we have seen? Resins, cation resin, anion resin. What is meant by resin? A small porous compound. Polymer, that is polymer and cross-linked polymers. And cation, SO3H group. And anion, quaternary ammonium salts. That is OH ion. Here H plus ions. Then regeneration, process, diagrams. Diagram, just how many cylinders are there in the diagram? 3 cylinders. What are the cylinders? Cation exchange cylinder, anion exchange cylinder, and degasifier by using a vacuum pump. This is about the external water. All these treatments we have learned. The last topic is what? Desalination. Desalination of water. What is meant by desalination? Desalination is nothing but, what is that? Is the process of removal of dissolved salt. Process of removal of dissolved salt, mostly sodium chloride from water, mostly sodium chloride. That is the desalination. And brackish water, water having dissolved salts with an average of 3.5% is known as brackish water. How much? 3.5%. Dissolved salts with an average of 3.5% is known as brackish water. Such water is fit for drinking? No. Such water is unfit for drinking purpose. So, how can you remove salts from brackish water? How can you remove? For desalination, that is reverse osmosis method. Reverse osmosis for desalination, that is removal of these dissolved salts, can be removed by what method? RO method. Reverse osmosis method. Reverse osmosis. Osmosis method. So this is the topic we have to learn. So they will ask you, what is the question? Reverse osmosis method. What is that? Reverse osmosis. RO method. Reverse osmosis mean, what is meant by osmosis? If osmosis is like this and reverse osmosis, opposite side, what is meant by osmosis and what is meant by reverse osmosis? Osmosis, we studied in 7th or 8th class. Just our cells act as a bacteria. So first of all, we have to know the diagram. Then it is very easy. The simple diagram I will draw on the blackboard. Please note down. Please draw it carefully. So drawing is very, very important in this one. Okay? Please draw this diagram. This is the diagram for osmosis. This is the semi-permeable layer. And this is the cantonment water or salt water or brackish water. You say brackish water, concentrated water. Finally, we say the concentrated water. And this is the low concentrated water. Low concentrated water. Here, this is the osmosis. And here the osmotic pressure. Osmotic pressure. So osmotic pressure is applied here. And this is what? Solution. What solution? Concentration solution. Or contaminant solution. Or salt solution. And this is the pure water. Okay. So this is the diagram, osmosis diagram. And reverse osmosis, just Same diagram, same permeable layer, and same contaminant or most concentrated salts. This is the pure water. And here, applied pressure. We can applied pressure. Applied pressure. So now think about in the osmosis exactly reverse this one. So if you know the osmosis, then automatically we can know the what reverse osmosis. So what is the definition of osmosis? First we know that osmosis. What is the definition? Anybody please tell me the definition of osmosis? Okay. When two solution of unequal concentrations, unequal, this is the more concentration, this is the less concentration, more concentration, less, unequal solution separated by the semi-permeable layer. The two unequal solutions are separated by or kept separated by a semi-permeable membrane. Solvents flow from lower concentration to higher concentration. Solvent flows from a region of lower concentration to higher concentration is known as osmosis. What is that pressure? Osmotic pressure. Osmosis. Okay? That is about the osmosis. Exactly. It's a reverse. What is the reverse? Mean the two unequal solutions separated by the what? Semi-permeable layer. So if here osmotic pressure is there, here applied pressure. If it's hydrostatic pressure or applied pressure, we can say hydrostatic pressure or applied pressure. If a hydrostatic pressure over osmotic pressure is applied to higher concentration side, or more salt side, what happened? The solvent flow is reversed. Mean from here to here. The solvent flow from here to here. But here the solvent flow from here to lower to higher. Here the higher concentration, here the lower concentration. Here the higher concentration, here the lower concentration. So higher concentration to lower concentration. Once again, what is the reverse osmosis? If a hydrostatic pressure or applied pressure over osmotic pressure is applied at higher concentration side, the solvent flows from higher concentration to lower concentration. This process is called what? Reverse osmosis. What is the reverse osmosis? That is higher concentration to lower concentration. This process is also known as superfiltration. What is that? Superfiltration. This is the reverse osmosis. This is the osmosis. Here superfiltration. Reverse osmosis also known as what? A super filtration. So what type of membranes are used? This is very important. What types of membrane? So that will ask you in the objective questions. They are what? Cellulose acetate. What is the name? Cellulose acetate. cellulose acetate. And another name, is there anybody? Cellulose butyrate. Cellulose butyrate. So in this, once again, if you know osmosis, then automatically we know the reverse osmosis. Always osmotic pressure or osmosis mean from lower concentration to the water flow from lower concentration to higher concentration. In the reverse osmosis, the flow of water from higher concentration to lower concentration. Higher concentration to lower concentration. Here, lower concentration to higher concentration. That is the reverse osmosis. Okay? The reverse osmosis is also called as what? Superfiltration. And what type of membranes are used? That cellulose acetate or cellulose butyrate also used. So these are the semi-permeable layer. And I will ask you one more question here. So in natural human body, for example, here I will use one tree is there here. One tree. This is the roots of the plant and this is the water. Okay. So salts are good for human being. So just you put the salt here. What salt? Sodium chloride. Sodium chloride. 1 kg or 2 kg of salts. Just to put here or mixed or dissolved in water and poured here. Okay. So what happened? It grow well or die? Is it die or grow well? What is the answer? You know the osmosis. What osmosis occurred in this one? Or what osmosis occurred? And one more. In our home, our mother prepared chutneys, mango pickle. Pickles are many, mango, lemon. In that what we have used? Oils, salts. Lot of amount of salts are used in that. So what happened in there? What happened? That is osmosis occurred. What happened in this higher concentration water? Mean if the salts are more here, mean what happened? More salts are there mean that always water lower side to higher side. Osmosis takes place in plant. Mean complete whatever the water is present in the tree. Present mean all the cells of the tree. What happened? Complete water is dehydrated. Complete water from the tree comes out. And automatically the tree will die. The tree will die. And same thing up in the bacteria. For example, the pickles are more concentration. If bacteria or fungi try to enter into the pickles, what happened? That higher concentration, the body water, the water of the bacteria present in the bacteria body, slowly, completely, that water flow from the bacteria into the chutney or into the pickle or higher concentration. Automatically bacteria will die. That is the reason all pickles are very fresh every time. Because the reason osmosis takes place. So this technology is used by reverse osmosis for purification of marine water or brackish water. So in the Europe countries, especially Denmark, Sweden, so almost they are using this method. Nowadays we also use it in our college also, RO method water, RO, Kent water, AquaGuard water. These are all used only this method. And also we have to measure the ppm level. How much ppm level? 150 or 200 or 250 is the measurement. So if that ppm levels are increased, we can't drink it. We have to purify. So that is the reason nowadays it's famous for drinking purpose. Okay. So this is applications. Okay. Thank you very much.